Hello class. In this video I am working the exercise on page 2 of your section 4.3 note packet on the law of cosines. And so we are given at the top of page 2 the three sides of an oblique triangle. We're given side A is equal to 10 units long, side B is 8 units long, side C is 5 units long. And using the law of cosines, we can figure out what angle A is, the size of angle A, size of angle B, and the size of angle C. So given three sides of an oblique triangle, okay, this in your textbook is called an SSS problem. Okay? So whenever you're given three sides of an oblique triangle, you need to use the law of cosines, start off with the law of cosines in a way, in figuring out what the three angles are inside the triangle. So the first angle I'm going to figure out is angle A. So I'm using the top equation on page 1 of your notes. And we have side A squared is equal to side B squared plus side C squared minus 2 times side B times side C times the cosine of angle A. Now you can substitute for little a, little b, little c, and then solve for cosine A. I prefer to solve for cosine A first and then substitute for little a, little b, and little c. So it requires some algebra, but what I can do is I can move a squared to the right hand side of this equality via subtraction, by subtracting a squared from both sides. And then I can move the 2bc times cosine A to the left-hand side by adding 2bc times cosine A to both sides. And so when I do that, I get 2bc times cosine A is equal to b squared plus c squared minus a squared. And then on the left-hand side, cosine A is being multiplied by 2bc. So if I divide both sides by 2bc, I isolate the cosine A on the left, and on the right I have b squared plus c squared minus a squared over 2bc. And so now on the right-hand side, now that I've isolated cosine of angle A, I substitute for a, b, and c on the right-hand side. And when I simplify the numerator, I get minus 11, and when I simplify the denominator, I get 80. So the cosine of angle A is equal to minus 11 over 80. Well, doing that division on my calculator, cosine angle A is equal to minus 0.1375. And so angle, if I take the inverse cosine on both sides, I get angle A is equal to the inverse cosine of minus 0.1375. Now you might recall that the output angles, or the range of the inverse cosine function, is angles from 0 degrees to 180. 0 to 90 are acute angles, and 90 to 180 degrees are obtuse angles. Since we're taking the inverse cosine of a negative number, we know that angle A is going to be an obtuse angle, okay, between 90 and 180. And so when I use my calculator, right, I discover that angle A is equal to 97.9 degrees. Okay? So I just used the first equation from the law of cosines on page 1 to solve for cosine A, plug in for little a, b, and c, and then when I took the inverse cosine, I get angle A is equal to 97.9 degrees. Now, in solving for angle B or angle C, it doesn't matter which one you solve for, right? You can pick and choose whether you want to solve for angle B next or angle C. Now, the good news is, in an oblique triangle, there can only be one obtuse angle. And we found it in for this triangle, right? It's 97.9 degrees. So if you wanted to switch to the law of sines in calculating either angle B or angle C, that would be fine. When you switch to the law of sines, though, you always have to be cautious because the largest angle that the inverse sine function will give you is 90 degrees. It'll never give you an obtuse angle. Okay? So, but we know that what the obtuse angle is in this oblique triangle, so we automatically know that angles B and C are going to be acute angles between 0 and 90 degrees. So you could switch to law of sines now if you wanted to in calculating either angle B or angle C. But I'm going to stick with the law of cosines, because that's what this section is all about. So let me rewrite my result up here, that angle A is 97.9 degrees. So I'm going to solve for angle B next, and using the second equation from page 1 of your packet, we have B squared is equal to A squared plus C squared minus 2 times A times C times the cosine of angle B. And so, like I did with angle A, I'm going to solve this equation for the cosine of angle B. I'm not going to put all the steps up here, right? You should be able to follow the steps from the previous equation. And we have the cosine of angle B is equal to A squared plus C squared minus B squared over 2 times A times C. And now I substitute for little a, little b, and little c, and I have the cosine of angle B is equal to 10 squared plus 5 squared minus 8 squared over 2 times 10 times 5. The numerator is equal to 61, and the denominator is equal to 100. Well, 61 divided by 100, you know, is 0.61. So when I take the inverse cosine of both sides, I get angle B is equal to the inverse cosine of 0.61. Since we're taking the inverse cosine of a positive number, we know that's going to be an acute angle. Which I said earlier, a moment ago, that angles B and C have to be acute because angle A is obtuse. Okay? And so using your calculator, right, angle B is equal to the inverse cosine of 0.61. We get angle B is equal to 52.4 degrees. Clearly an acute angle, right? So now we have 2 of the 3 angles. You could use law of sines, law of cosines to find angle C, but it's not necessary because you know that A plus B plus C has to add up to 180 degrees, right? And so A is 97.9 degrees. B is 52.4 degrees. C is the unknown. And so when you solve for C, you get C is equal to 29.7 degrees. And so we have found the 3 angles of this oblique triangle. Okay? A is 97.9 degrees, B is 52.4 degrees, and C is 29.7 degrees. Okay?